First of all, write an equation for the formation of cyclopropane, a carbon in the form of graphite and hydrogen gas. It will produce cyclopropane. The molecular formula for cyclopropane is C3H6. Now balance this equation, multiply this carbon by 3 and hydrogen would also be multiplied by 3. Now for formation of 1 mole of cyclopropane, you have to atomize 3 moles of carbon. Carbon is in solid form and it must be converted into gaseous atoms. So to convert 1 mole of carbon into gaseous atoms, we require 717 kilojoule per mole. So for 3 moles, 3 multiply 717. Now you have to break 3 hydrogen to hydrogen bonds, H to H bond, and the bond enthalpy for 1 mole of H to H bonds is 436. So for 3 moles it will become 3 into 436. Okay, now if I talk about cyclopropane, there are total 6 carbon to hydrogen bonds, as each carbon of cyclopropane is connected with 2 hydrogen atoms. So there are 6 carbon to hydrogen bonds, and in order to form 1 mole of carbon to hydrogen bond, the energy that is being evolved is 410 kilojoule per mole. So minus 6 into 410. Why I put negative sign here? Because during bond formation energy is released. And if we talk about carbon to carbon bonds, so there are 1, 2 and 3 carbon to carbon bonds that are being formed in this reaction. So minus 3 carbon to carbon. Now this is what we have to find, and the total enthalpy change for this whole process would be equal to enthalpy change of formation of cyclopropane that is given in this question, and it is plus 53.3. Now if you solve this all, you will get 999 minus 3 carbon to carbon, it equals 53.3. so for 3 carbon to carbon it will become 53 minus 3 into 999. Now if you subtract 53.3 from this, you will get 945.7 for 3 carbon to carbon. This negative sign will be cancelled. So for 1 carbon to carbon bond, that energy would be 945.7 divided by 3, and you will get 315.2 kilojoule per mole. So the average bond enthalpy for 1 mole of carbon to carbon bond is 315. So correct option in this case is beta 315.